Hey everyone, so for Material World, I decided to do stage 2 and I did the sugar and bicarb experiment. So let's investigate. So our testable question was what happens to sugar and bicarb when we change the amount of heat used? And the syllabus links were the outcomes, questions, plans, and conduct scientific investigations, collects and summarizes data, and communicates using scientific representations, and describes how adding or removing heat can cause a change of state. So those were the two main outcomes that were focused on in this particular experiment. So the prediction was that the bicarb and the sugar will change when we add heat. And let's go into the method. So as for materials, we needed 200 grams of sugar, 5 tablespoons of honey, 2 teaspoons of bicarb, a measuring cup, a stovetop, a pan, and a baking tin lined with baking paper. And as for the method, so step 1 was to line a square tin with the baking paper, which I'd already done in that materials section. And then basically you just stir in the 200 grams of caster sugar and the golden syrup or the honey together in a deep saucepan over a gentle heat until the sugar is melted. So until it sort of looks like that. And you're not supposed to, so you try not to let the mixture bubble until the sugar grains have disappeared. So that's sort of what it looks like in the photo there. And then by step 2, that's what it looks like when it's completely sort of melted and you can't really see the sugar grains anymore. So once it's completely melted, you turn the heat up, you let it simmer and bubble until you have an amber colored caramel, which is basically what is in this picture right now. And then as quickly as you can, turn off the heat and you tip in some of the bicarb soda and beat it with a wooden spoon until it's all disappeared and the mixture actually foams up. And then you scrape the tin, scrape it into the tin immediately and be careful because the mixture is very hot. So step 3, the mixture will continue to bubble in the tin and then you just leave it for about an hour to an hour and a half and the honeycomb will be hard and ready to crumble or snap into chunks. So that's what it looked like when it started to foam up in the pan, and then that's what it looked like when I poured it out. So as you can see, it changed dramatically from this like liquidy texture to adding the bicarb and it looks like this. Step 4, just repeat all these steps without adding heat and then compare the difference of what happens. So as for observations and results, as you guys saw in that last photo, when we added the bicarb, the mixture foamed up and reacted, causing bubbles and an increase in size and change in the texture of the mixture. When no heat was added, the mixture stayed the same. There was no reaction between the sugar and the bicarb. It was just like mixing two powders together. That's what it looked like when it came straight out of the pan. And then these bottom 2 pictures are after I left it for about 45 minutes to an hour. As you can see, it's like a honeycomb texture, and then it was hard enough for me to break off into little pieces. As for the conclusion, the sugar and bicarb had a reaction when the heat was added, the mixture bubbled and foamed up and then later hardened into what is known as honeycomb. When no heat was added, there was no observable reaction. The sodium bicarb reacts when you add it to the hot sugar syrup. This is due to the heat of the solution breaking down the sodium bicarb into carbon dioxide, water, and sodium carbonate. So it's just basically breaking down the bicarb. As for working scientifically skills, so Material World focuses on questioning and predicting, so identify and pose questions in familiar contexts that can be investigated scientifically. So identifying questions that can go along with the experiment and making predictions based on prior knowledge. They might have some prior knowledge of, what happens to water when it's cold and then it's heated, or what happens to other materials. So they might have a viable prediction as to what might happen when the bicarb is added with heat. They might not exactly know what's going to happen, but I'm sure they'll be able to definitely make predictions about it. And then as for planning and conducting, so plan scientific investigations with guidance. I think guidance is very important because I would not allow my primary school students to do this experiment by themselves as it has quite a lot of safety risks. Conduct scientific investigations to find answers to questions. So what happens when you add heat? Use appropriate materials and equipment safely. So this is a big one. This would be something you would really have to you would basically have to do the whole experiment if you were doing this with a stage 2 class. I don't think it would be suitable to allow the students to be stirring over such a hot pot and then pouring it into a pan. The mixture does get really, really, really hot and it bubbles up very fast. So you'd probably be best with your students just observing you, but they could definitely help with measuring the ingredients, and maybe stirring it initially, but definitely with a lot of supervision and protective equipment. Consider and apply elements of fair test, so the measuring cup, the measuring spoon, adding the heat, the timing and everything like that. Collect and record accurate, honest observations using labelled observational drawings, basic formal measurements, and digital technologies as appropriate. Reflect on investigations, including whether the testing was fair or not, and participate individually or collaboratively with clear roles and goals. As for design and production, research and planning, so identify and design a problem with consideration of practical and aesthetic needs, consider sustainable use of resources and time constraints in planning design solutions, and develop, record, and communicate ideas and decisions using appropriate technical terms. Produce labelled and annotated drawings, including digital graphic representations, and plan a sequence of production steps when producing design solutions individually and collaboratively. Producing and implementing, so select appropriate tools for a specific purpose, select and effectively manipulate appropriate materials for a specific purpose, use safe work practices, and consider sustainability and constraints when choosing resources and managing time and production of design solutions. So design and production tasks, our stove top has stopped working. Is there another way we could produce enough heat to test this same experiment? Or how else could we measure the ingredients if we didn't have traditional measuring equipment that we use? So we had no measuring cup, for example, or no measuring spoons. How else could we accurately measure? These are good tasks to get the kids thinking and get them sort of designing and implementing parts of the experiment. Syllabus links, so just basically the outcomes that I read out before. And then as for content, just recognizing that a change of state can be caused by adding or removing heat, and predict and observe the effects of adding or removing heat on a variety of solids and or liquids. And that's about all, everyone.